Good morning, geometry students. We are here today to talk about secants, tangents, and angle measures. So we have a new term that we've never seen before here, secant, and that's exciting. So let's get started. You can't see it, but I'm giving a thumbs up. So this lesson is going to focus on a new type of segment in circles and how the special circle segments relate to one another. So our new special segment is a secant. A secant is a line that intersects a circle in exactly 2 points. So here, this green line is a secant. We've already learned about chords, radii, diameters, and tangents. So this is the last special kind of line that we have with circles. So that's exciting and cool, right? Yes. Yeah. Okay. So you want to write down this definition and maybe draw the example. You don't have to draw all the special lines and segments, but like definitely draw an example of what a secant is so that you have that. Okay, when two secants intersect in a circle, the angles formed are related to the arcs that they intercept. So we have this theorem to write down. If two secants or chords intersect in the interior of a circle, then the measure of an angle formed is 1/2 the sum of the measure of the arcs intercepted by the angle and its vertical angle. So here we've got these two secants cross and they form these two angles, right? So angle 1, that's this guy, is half the sum of arc CD and arc AB. And then since they're vertical angles, this one's also the same. It's also the same measure as angle 1. And then we've got these angles here, angle 2 and its counterpart, its vertical buddy, we'll call also 2, are 1/2 the sum of this arc BC and this arc AD, right? So that's a useful property that will have some problems that require us to use that to solve them. Yes. Ready? Write it down, draw your picture, write down these formulas. They're important. Maybe down on the next slide. Okay, so 2 sample problems using this theorem. I decided to put into the slides not just sample problems that use only numbers, but also ones that use x's so that we can practice with both kinds. And there's going to be, so your check-in quiz on Canvas is going to be like formatted the same as the questions on this. So there's 10 questions on the slides, there's 10 questions on the check-in quiz, and there's, one that's this with just the numbers, one that's this with the x's, and then so on. As we work through, we'll see all of the problems, all of the problem types that we have. So here we have our two secants intersect, right? We want to know this angle here. It's marked with a question mark. That's how we know it's the question. Okay, so didn't do a very good job of drawing that, but we know from our theorem on the last slide that this angle is 1/2 the sum, that means adding, of these arcs. So 1/2 of 55 plus 187. I've put my calculator just out of reach again, so that'll be, let me grab that. Okay, so we just want to, I can even type this into the calculator exactly as is if I wanted to. So 55 plus 187, just like that. Hit, yeah, that's the enter key. Hit the enter key, tells me it's 121 degrees. 121 degrees. Done. Problem 1 solved. That's it. Got it? Cool. This one, a little trickier, right? We're given this arc and this one, and we need to find this angle. So We're going to set up an equation. I'll put it up here. 32x plus 2 equals, and since that's the angle, it's 1/2 the sum of the arc measures. So 17x plus 145 in here. Gotta put the x, my bad. All right, so I would start distributing that 1/2. So half of 17 is 8.5. 8.5. Ooh, wow. That was supposed to be a decimal point, not a weird streaky thing. 8.5 plus 145 divided by 2 is 72.5. God, I keep forgetting that x. It happened again. All right. So 32x plus 2. So I'm going to subtract this 8.5x over to here and subtract this 2 over to here. And 32 minus 8.5, my calculator says that is 23.5. X is left. 72.5 minus 2 is obviously just 70.5. And then we want to divide. I'm not going to write down all that division, so divide. No. 70.5 divided by 23.5 is 3. All right, so I'm pretty sure that these questions are just asking you for x, because that's what they ask for. It says find the value of x. So x equals 3, and that's it. We're done. Okay, so we solved 2 problems using that property. These are the same kind of problems we're going to have on our check-in. And now you've seen how to solve them. You've seen the examples of similar problems. So hopefully that's good. You can just take this information and apply it to your check-in quiz. And make sure you get it all written down, because that'll make it a lot easier. Meet me on the next slide. Okay, so we want to remember that Theorem 10.6, which is a long time ago, states that the measure of an inscribed angle is half the measure of its intercepted arc. If one side of the angle is tangent to the circle, this relationship still holds true. So we've got ourselves a new theorem. We want to write this one down. If a secant and a tangent intersect at the point of tangency, then the measure of each angle formed is 1/2 the measure of its intercepted arc. I thought I had a picture of this. I'm not going to attempt to draw one, but there's examples on the next slide. So get that written down, pause the video if you need to, and then just scroll on. Well, I'll scroll on and you'll see the next slide. There are examples. So 2 practice problems relating to that theorem from the previous slide are these. So we've got here an angle of 75 degrees, and we want to know the measure of this arc, right? This arc does not correspond with this angle. So this is an inscribed angle, which means it's half as big as its intercepted arc. So this part, this intercepted arc here, let me erase the other one so that you're not super confused. This arc, right, the one that's in green now, is twice as big as 75. I know that twice as much as 75 is 150. If you don't know that, you can check, but it is. And I know that a whole circle is, I'm pretending that you're all telling me numbers, and that someone just said the right number is 360. So 360 is a whole circle. We see that this arc is everything except 150, so we just subtract 360 minus 150. That's 210. So question mark here is 210 degrees. All right, I erased the 360 minus 150, but I'm just going to put it up here so that it's in a better place. 360 minus 150, 0, 1, 2. All right, so then this next one is a little trickier, right? So change our pen color. I'm going to change it to like a different color. Okay. So this angle here, once again, is half as big as its arc because it's an inscribed angle. So we need to multiply that by 2 and then subtract it from 360 to get what 261x minus 1 equals. So 360 minus 2 times our angle 49x plus 1, not 4x, 49x plus 1 is equal to 261x minus 1. We distribute our 2. Okay. 2 49s is 98. So we get 360 minus 98x plus 2. Let's do this, 98x plus 2. I think it's actually, since this was negative, we got to make this negative too. Minus 2. So 360 minus 98x minus 2, 261x minus 1. And then I'm going to, combine like terms. 360 minus 2, that's 358. I'm going to go ahead and I'm going to plus this 98x to the other side now, just to save myself a minute. 261 plus 98x is 359x. X minus 1. Still got this 1 over here, so let's add that. Plus 1 over here. Then we've got 359 equal to 359x. Kind of suspected this from the beginning of the problem because of how big these numbers are. We divide out that 359 and we get that x is equal to 1 and we're done, right? So just solving for x. A little trickier on this type of problem than on the ones from the before, but still I think manageable. You guys are pretty clever. I think you can handle it. All right. So we're going to move on down. Make sure you get this all down, write it down, copy it. Just said the same thing 3 times, you guys. Pause the video if you need to, and then meet me down on the next slide. All right. Secants and tangents can also meet outside a circle, and the measure of the angle formed also involves half the measures of the arcs they intercept. I don't know, that sentence doesn't actually make sense to me. I don't know why I wrote it. Anyway, we want to write down this theorem 10.14 now. If two secants, a secant and a tangent, or two tangents intersect in the exterior of a circle, then the measure of the angle formed is 1/2 the difference of the measures of the intercepted arcs. So difference means we subtract, and that's the only major difference between these next 6 problems and the previous 2 problems. There's going to be 6 different problems because we've got 3 different ways for this to happen. We've got the 2 secants, the secant and a tangent, and the 2 tangents way. So we'll cover what it looks like if it's 2 secants, what it looks like if it's a secant and a tangent, and what it looks like if it's 2 tangents. So make sure you get the theorem down. Meet me down on the next slide. we're ready to go, right? Here's a picture of what that looks like. Two tangents meet like this. We already have seen stuff like this from last week on our tangents lesson. Two secants, that looks like this. And then a tangent and a secant would look like this. So we got, you probably can't see what I've just done. Tangent and secant, two secants, two tangents. I assume you guys can read as well. So all this has got to do with these arcs that they intercept. And we're about to cover how you solve those problems. Right, so next slide. Practice problems with have two secants that intersect outside the circle. Right, once again, just numbers here, letters on this one, expressions with X. So we are looking for this arc, and we know that this angle is 1/2 the difference of these arc measures. So 50 is equal to 1/2. It's question mark. I'm going to call it X minus 55. All right. So we can distribute the half, or we can just multiply by 2 to get rid of the half, because 2 and half are opposites. I like multiply by 2 better. I think that sounds nicer. So 100 equals X minus 55, right? Obviously, to get the X by itself now, we got to add 55. Also, I made your check-in for this lesson multiple choice again, you guys, instead of type in a number. You're welcome. All right, 155. That's it. That one was that simple. Question mark's 155 because this minus that has to be twice as big as 50. 155 minus 55 is 100, which makes that angle be 50. Next. So this one looks a little trickier. Same basic concept. We're just going to have more x's in our equation. So 2x plus 8 is equal to 1/2. I'm going to put it in square brackets. So 12x minus 7 minus parentheses 6x plus 1, close parentheses, then close the bracket. And the reason I put the parentheses here is because we're subtracting, so we got to distribute that minus. This is a lot. All right, so I wish there was like a copy paste function on this thing, but there's not. 2x plus 8 equal to 1/2 12x minus 7 minus 6x minus 1. Right, combine our like terms. 12x minus 6x leaves 6x. Negative 7 minus 1 is negative 8. Parentheses, put that half there. Still have 2x plus 8 over here. Distribute this half. This time I'm okay with it because these both have even numbers, so it'll be easier to distribute it than it would have been over here when they were both, this was 1x and this was 55, so odd numbers. Half of 6x is 3x's, half of 8 is 4, and then we just got to combine our like terms. I'll add the 4 over here, I'll minus the 2x, so add 4 minus 2x. Okay, got that. 8 plus 4 is 12. 3x minus 2x is just x. So we're done. X is 12. It was a little trickier, but again, nothing that you guys can't handle. you guys are pretty with it most of the time, you know? I believe in you. And especially once you've seen an example, there's nothing that can stop you from solving the problems. All right, so make sure you get this down, pause it if you need to. I know I moved kind of fast. I hope you are, pausing it as you need to throughout the lesson as well, when necessary. And then just meet me on the next slide for practice problems that are secant tangent. For some reason, this one set of square brackets did not erase. Okay. This. So we've got now one secant and one tangent intersecting outside the circle. Why is it back? Okay. Once again, we've got one that's just numbers and one that's got an x, a variable, not, three things all with variables this time, luckily. So set this one up. 60 is equal to 1/2 of 190 minus our unknown, which we're going to call it x, though I do not need to. Once again, this one's even, but this is still 1, so I'm going to multiply by 2 instead of distributing the 1/2, which gives 120. The 2 cancels that out, equals 190 minus x. Subtract 190 to get x on its own over here. All right, negative 70 equals negative x. Since they're both negative, we just cancel it out. Leaves us with 70 degrees right here. This is a really nice color of like bluish purple, periwinkle. Anyway, we're going to do the next one now. All right, setup pretty much the same. Let me scroll up a little. All right. So we've got 8x minus 7 equal to 1/2 times 200 minus 90. It's really nice when there's only one x, because like you can just simplify this whole side. And that's what I'm going to do. Put it in my calculator instead of like taking it step by step. If you wanted to, you could do the 200 minus 90 and then take the half of it, but calculators can do the whole thing all at once. Half of 200 minus 90 is 55. So then we know that was a bad 8x plus, not plus, 8x minus, oh, it is plus. I'm being silly. 8x plus 7 equals 55. We're going to subtract our 7, 8x equals 55 minus 7 is 48. All right, to get x by itself, we divide by 8 on both sides. So x equals 6, and we're done. All right, once again, make sure you get it down. Pause the video if you have to. And then we got one slide left, 2 more problems, and then you're good. There's no Khan Academy for this lesson. It's just the Canvas check-in. Those brackets are back. They're just really following with the whole thing today. I want to scroll down a little more, and they're back again. All right, that's crazy. I don't understand why sometimes it works and sometimes it doesn't. All right, last 2 examples we see here. Our unknown thing is the angle. We see that we know this arc is 233, which is great. Thanks for telling us that, but it doesn't tell us the other arc. So how can we figure it out? Well, you see, friends, this piece, since they're 2 tangent lines, it breaks the circle into 2 arcs. So whatever this arc is, this arc plus that has to add up to 360. So this arc, we can easily figure out what it is by doing 360 minus The darker pink, 360 minus 233, tells us it's 127 for this arc. Can you read that? Probably not. If I have to ask, I should assume someone can't read it. 127 degrees. So our unknown question mark equals 1/2 of 233 minus 127. And once again, I'm just going to put that into my calculator. But if you wanted to do step by step, 233 minus 127 first. And then just divide it by 2. Our answer, we only want that bottom one, is 53. So our unknown is 53 degrees. Circle that because it's our answer. All right. Let's see. I'm a big fan of that purple color, so we're going to use that again. And last one. This one's got 3 x's again. It's a lot, but we can do it. We're going to power through. Okay. So 5x plus 7 is equal to 1/2. Okay. This is the bigger one, the 23x plus 7. You know what? Despite the fact that the square brackets are following me, I'm going to use them again. Minus parentheses 14x minus 17. Close the parentheses, brackets. Okay, still got to distribute that minus into these parentheses. Just going to copy the rest all down. 5x plus 7 equals 1/2. That was a really bad attempt at a parenthesis bracket thing. Bracket 23, not 2x. 23x plus 7 minus 14x, because we've distributed the negative. This is a negative times a negative, so it's going to be plus 17. Okay, combining like terms, we got our 23 minus 14 is 9x. Our 7 plus 17 is 24. Brain wasn't having it. Okay, in parentheses, still the 1/2. Still equal to that. This one, since this is an odd number, instead of distributing that 1/2, I'm going to multiply by 2. So 2 times 5x is 10x. 2 times 7 is 14, equal to 9x plus 24, because remember, multiplying by that 2 just gets rid of the fraction. And then we just gotta switch our stuff around so we get x by itself. We can subtract 9x here and here so that there's only x's on one side. We can subtract 14 here and here. So we've got just one x over here. 24 minus 14 is 10. So x is equal to 10. That was a really poorly drawn box. I'll rewrite x equals 10. Redraw the box. There we go. X is 10 on this one. Okay. And that is it. That is how you solve each type of problem that we have talked about today with secants and tangents and angle measures. Hopefully that is good and helpful. If you still need help with the Canvas check-in, just reach out, email, office hours. I'm here all the time because there's nowhere else to be. All right. See you guys next time.